Alrighty guys, we are here with some extra credit / a really good study tool for this cumulative test that's coming up. So this is what it looks like in all of its glory. It's a little flip book to go over graphing, to go over excluded values, to go over how to multiply and divide fractions. Well, you got to do that part. So I'm going to show you guys how to make this. So you're going to need 3 sheets of paper. Yes, just 3 sheets of paper. And you're going to line them up as best as you can, just leaving yourself enough room to write. And then after that, once you've lined up your 3 sheets of paper, you're going to take and fold the bottom part up. And then what you have created is more rows of this. And just fold it nicely, and then so you can see I just folded it right there. That's what it looks like. And then you're just going to take the stapler and staple it really close, as close as you can to the top, so that you can actually still flip through this thing. Okay, so that's what that looks like. Now, I like Sharpies to highlight this kind of stuff, but if you don't have a Sharpie, don't let that deter you from doing this extra credit. This is awesome extra credit, and it's a good refresher. You're just going to write down the things that we have covered in this chapter. So we are doing factoring, and then the next one we're going to make is on graphing. Okay, so the next little tab is going to be excluded values. Simplifying. And LCDs. So we know those least common denominators. Then we're going to go over multiplying and dividing rational expressions. And then you should have a tab for adding and subtracting. And then you're going to need a tab for solving rational equations. Alright, so those are your 6 tabs that you're going to need to get the extra credit for this unit. And now we're going to move on to the expectations of each tab. The first couple of ones are done for you. So I'm going to put them up on the screen, and then you are literally just going to copy it down. So we learned, so you need to have these 2 lines right here, these 3 sections. The most basic form of factoring is the GCF, and that's where we hockey stick. So off to the side here, if you want to write hockey stick, if that's the method you use, then write that down. Then we also go into trinomials, so if they have 3 terms, we can t-chart them. Notice there's 2 examples, one example without a leading coefficient other than 1, so this one has a coefficient of 1, and one with something different, okay? So you might even want to write the cross multiplying part where this is negative 4x and positive 27x, and when you add those together you get the 23x. Then we went into things that have 2 terms. So these had 3 terms. These ones have 2 terms. You have your difference of squares, which is x squared minus 81 and 4x squared minus 25. Those are 2 types of difference of squares. And the sum and difference of cubes one. So this is the pattern. Plus or minus cubes, factors, little and big, parentheses, a, b, a squared, ab, b squared, the signs go, soap. So remember with the signs, the same sign, opposite, always positive. Same sign, opposite, always positive. And then here's your example for that. And then if it has 4 terms, we factor by grouping. So we split it up into groups. We look at these two and go from there. And embedded in this really good grouping problem is this x squared minus 16, which means this can be factored to x plus 4 and x minus 4 because it's a difference of squares. So you always have to check to see if you can go further. Now, I'm going to move on to the next set for graphing, but if you obviously didn't get that copied down in the time I was talking, then what you need to do is just pause the video right now, get it copied down, and then you can move on when I move on. Okay? Alright, for graphing, when we're graphing rational expressions, there's 4 key characteristics that make life really easy for you in the beginning. So first of all, you're going to need to know how to find your vertical asymptote. That's this guy right here. What you'll notice is it's going to be the excluded domain, so x cannot equal 2, so it puts an asymptote there to say don't equal me. Then you need to know how to find your horizontal asymptotes, and we learned that if the powers of the numerator and the denominator match, then we can find the horizontal asymptote just by dividing the numbers in front of the x's, or the leading coefficients of each numerator and denominator, which is why this is 1. We learned that if this one is less than this one, so if it was x over x squared, then the default horizontal asymptote is y equals 0. And if the numerator power of x is bigger than the denominator power of x, then there is no horizontal asymptote. So those are our choices. Either y equals 0 if it's less than, y equals the ratio of the coefficients if they are the same, like this guy, and then none if the numerator power is bigger than the denominator power. X-intercepts you're going to do right here. Here's the math for that. Here's the math for the y-intercept. So my x and y-intercepts are here, which these graphs like to coast along their asymptote, so it's clearly going to be in this quadrant. So whenever you're deciding what to do with these guys, you have to look at the vertical asymptote, and then the graph, is it going to be above the horizontal asymptote or below? Well, because both of these points, my x and y intercept, are below, the graph is going to be there. Then I have to switch to the other side and figure out where those points are going to be. So I have to pick a point in that quadrant. So since this is at x equals 2, I'm going to pick a point like 3, and I get 7, and so therefore it's going to coast along the asymptote up there. Okay, that's graphing. Again, I probably went too fast for you to be able to copy this down. Also, you can get this in class from me. I'll try and remember to talk about it, so if you want a nice pretty graph, you can have one. Otherwise, draw one in, I don't mind. Okay, at the very beginning of this chapter, we went over excluded values and simplifying and LCDs. So here are how we find the excluded values. Here is how we simplify right here, and here is how we find the LCD. So we did lots of practice with those. Again, I'm going to go so fast that you're not going to be able to copy these down, but these are 3 examples that you can pick, and if you look at your notes, they're the examples from your notes, so it's not like I'm asking you to reinvent the wheel. Alright, next you're going to notice that there is no examples on this page because it's extra credit. I'm not going to give you extra credit for copying. So you need to go to the notes where we multiply and divided rational expressions, and on one side you're going to have a multiplying example, and on the other side a dividing example. And you're not going to pick the easiest one because that's not helpful. You're going to pick the one that challenges you, because if it's hard, it probably means you're learning, and it probably is something you need to practice. I mean, that makes sense. It's not fun. We don't like to be challenged always. Some of us actually do like to be challenged, but maybe not in math. So make sure you pick problems that are worthwhile. You're at the grade level and math level where you know what I mean by that. So same thing here, you're going to draw a line in between and do an example of adding a rational expression together and subtracting a rational expression together. And then you also are going to be doing 2 examples on solving rational equations. So just pick 2 really good problems from your notes to put on here as well. So if you do all that, you get 2% extra credit on your test, but you also get a fun little flip book that you can refer to whenever you need to. Alrighty, take care.